Hello, this is Roberto and this is the HVAC is my channel. Today we're going to be talking about the total effective length and the friction rate. Alright, so let's get into it. But before that, I hope everyone is enjoying these videos and all this education is totally for free. You just have to hit the like button and don't forget to subscribe. That helps a lot. All right. Okay, so let's get into it. So in the previous video, we were talking about the velocities in order to comply with the International Mechanical Code, actually with the ACCA standards. Okay, but now for the friction, what we're gonna do is we're gonna check on this part right here on this icon. So this icon is the blower. And in the blower, we're going to be able to see this part. So as you can see on the left, we're going to have the available static pressure, right? So the available static pressure is going to be for us 0.24 inches of water column for heating and cooling. But why are they the same? Because they are going to be the same since we assumed in the equipment heating equals cooling. As you can see in here, heating equals cooling. All right. But now the right side is what we need actually for the friction rate. So in the friction rate, we need to calculate the total effective length. Okay, so it's very interesting because this part actually used to confuse me. So I used to interchangeably talk about effective length and equivalent length. Remember, this is the total effective length, is not the equivalent length. All right, so for the total effective length, we're going to be able to see in here we have a total effective length of 214 feet. Okay, so since we have the available static pressure 0.24 and we have the total effective length which is 214, let's double check on this if this is going to give us the friction rate. And also what I'm going to do is I'm going to make another video based on that. Okay, so let's do this calculation. We have the left side, we have the right side, right here and right here. So what we're going to do is that friction rate actually is the available static pressure, which is going to be 0.24, so 0.24, there you go, divided by the total effective length. Okay, so the total effective length is going to be 214, so divided by 214 equals, so that's going to be my friction rate per feet. However, we always try to express this per 100 feet, so we're going to do that. We're going to do times 100. There we go. So in that case, we're going to be able to see is 0.11, as you can see in here, 0.112. So that's actually the friction rate. And why is it saying okay? So, okay, we have the friction rate right here. It's 0.112, which indicates my duct design is correct and is within the parameters. Okay, but you might ask Roberto, what are the parameters? So anytime you can go to Google and find out friction rate, ACCA, total effective length, and you're gonna be able to find a chart. For example, that's what I did in Google. I Googled this and then we have this chart. See, friction rate chart indicates that my friction rate should be between 0.6 and 0.18. I wouldn't go 0.18. I would go at least 0.14 for safety factor, because if you are here 0.18, you are very risky to get into the problems of fan is too powerful, decrease blower power speed, increase tail velocity. Mainly the fan is too powerful. You might run into those issues. Or if you are on 0.06, you are barely making it, so you might have like inadequate fan performance. See, so this is what they call the ACCA wedge. ACCA wedge. See, so anytime that you're between these numbers 0.06 and 0.18, your duct design is correct. But don't go to the extremes, right? You always want to be 0.08, 0.14, 0.02, and the magic number is 0.1. So for example, as we saw that, if you have in here a ductulator, usually what they do is, okay, so since we have this duct 14 inches, let's put that in a ductulator, and usually in the ductulator they assume a friction rate of 0.1. right? Why 0.1? Because as we saw in Google, 0.1 is the perfect number for a friction rate. It could be a little bit more, it could be a little bit less. Don't go to the extremes, ACCA Wedge, right? So that's what we obtained in here. But now that we have this number, so we are all good. But I'm gonna teach you a nice trick, because how do you calculate that? Because that's what the HVAC is my channel is about. Everything has to be easy. Let's not make things complicated. But the main reason also for this channel is to explain why, because I don't want this to be like a memorization process, like, oh, by memory I know this has to be between this and this. I like to explain why. Okay, so we're going to explain why and where does it come from. So it's going to be 0.24 divided by 214, which is the total effective length. Okay, but which length? Okay, it says length. Okay, so now let's go here to the duct layout. We're gonna go to the duct layout. You have a lot of registers. Well, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 3, 6, 9, 10, 11, 12, 13. So you have about 13 registers, right? And you have 2 returns. This is look at this. This is a very short distance. Even it doesn't have a distance. This is the longest distance of return. So we're going to measure the distance from the return, from the longest return, which is obviously this, because we have 2 returns, return 1, return 2. So the return 2 is the longest, as you can see. But we are in a problem. Why? Because in order to measure the total effective length, you need to measure the distance between the longest or the farthest return, which is this, to the farthest supply going through the equipment. So where is the farthest supply? Is it supply register number 1, 2, number 6, number 13? Which one? It looks like it could be this. It looks like it could be this or this. We don't know. So a very good trick is that Wrightsoft is going to show you which one is which. So in order to find what we call the critical path, the longest distance between the return, the longest return, and the longest register, is you go here in Wrightsoft, you right click. Once you right click, you're going to be able to find the properties sheet. Once you have the properties sheet, you're going to go to ducts. Here we have 1, 2, 3, 4, 5 tabs. So under ducts, you're going to be able to find this: show longest run ducts as thick lines. As you can see here, show longest run ducts as thick lines. So instead of no, you're going to click here and put yes, and then you click enter. There we go. Oh my gosh. Now you're able to find the longest path between who? Between the longest or the farthest return and the farthest supplied register going through the equipment. All right. So, you know, just out of curiosity, what is that distance? Because in here it's just showing us, as you can see, it's a little bit thick lines, right? You're able to notice, see? No. There we go. You're able to notice the thick lines. That's what we call the critical path, which means it's the longest run between the return. I'm sorry for the redundancy, but this is important. The return going through the equipment to the farthest supply. Critical path. Based on that critical path, let's be more curious. What is the distance, for example, for this return duct? This one right here, 12. What is the distance for this 12-inch duct? All right, what we're going to do is, again, right-clicking here, and then we're going to be able to go to the tab notation. Under notation, you have duct contains size only, but we're going to change it to size and length. There we go, and then enter. Finally, we're able to see the distance. So the length of this duct is 6.8 feet. Let's check. All right, we're going to be able to check right here in the blower static pressure, right? And then it says return. What is the equivalent length of fittings? I don't worry about that yet. So measure length of run out. The run out of the return is 7. Right here you have 7. Is it 7? Let's go checking here. Actually it's 7. Why? Because it's rounding it up. You're not going to be putting like 6.8. It's better to round it up because you want to be conservative. It's better to be conservative and adding more length than reducing length. So that's why 6.8 equals to 7 in the return. Okay. All right. We're going to be able also to see the other one. Let's do the return first. So what is this distance from the return? See, it's going to be from the return only. We're talking about only the return. Critical path has two parts. One part is the return part. The second portion is the supply section, supply part. Okay. So right now we're on the return path. See, the return path is going to be this. Number one, you are able to see the length of the duct. Number two, you need to take into account the fittings. What fittings? You have fitting 1 right here and fitting 2 right here. Those rectangles, right? Those squares. So it says fitting 6M and in here it says fitting 5D. ACCA Manual D already have a code for the fittings in order to calculate the equivalent length. So, okay, let's go there. Okay, we have 6.8 so far. Let's check. 6.8 is 7. There you go. It says equivalent length fittings 60. We're going to be able, let's check on that. Okay, so what is the equivalent length of this fitting? In order to know that, you click there, right? Right click. There we go. So that fitting is going to be what code based on ACCA Manual D. Fitting number 1 type is 6M. The code is 6M in ACCA Manual D. And Manual D and the laboratories already made some tests in order to find out what is the equivalent length. It says the equivalent length is 20. If you want to see pictures or more schematics, click on 6M. You click on 6M and you're going to be able to find out this. This is the 6M type of return air fitting. It looks like this, like a booth, and you have the duct. So based on the 6M, that's the ID. That's the code for ACCA Manual D. You have equivalent length of 20. You have a rectangular round 90 degrees elbow return booth, right? And if you have another disposition, see, you have a 6L, you have a 6J, depending, manual Wrightsoft already selects that, right? But now that we are here, what is equivalent length? It says 20, okay? So equivalent length is a dimension in length, dimension, compared to a straight duct. So for example, if you have a pressure loss for this picture or for this arrangement, and you put in the same pressure loss on a straight line duct, that straight line duct would be 20 feet. Okay, so you calculate two things. Number one, you calculate the pressure loss based on this, and then the same pressure loss you put in a straight duct, that's the equivalent length. Okay, so that's why if we put in a duct of 20 feet, that could be equivalent to the pressure loss, the same pressure loss of this arrangement. Okay, so that's equivalent length, is not effective length, right? Okay, so after the explanation, we're gonna go to the other equivalent length. So we're gonna go checking. Oh, we didn't check. This is 6M, 20. The other one is how much? Oh, there we go. This is the ID type is 5D. It's 40. So 40 plus 20 is equal to 60. So let's go on this. How is the arrangement on this? So you're going to click on fitting type number 5D. All right. In 5D, you're going to be able to see 40 is the equivalent length. See, 90 degrees round takeoff with transition, usually above the air handlers. So now we're going to be able to see in here in the return, it's 60. If you want more details, you go click on here and then you're going to be able to see the fitting type ID. See, fitting ID 6M, 5D, angle, and then equivalent length 20 plus 40. 20 plus 40 is equals 60. All right. The same process goes for the supply. For the supply you have, we're gonna go, let's check on the supply. Now that we have the equivalent length of the return, we're gonna go off the critical path. Let's go on the supply. Under the supply, see, this supply length is gonna be 8.8, and this, where's my critical path? This part, right? See, there we go. So it's gonna be equal to 8.8. Where's my calculator? Let's gonna grab the calculator. HVAC easy math channel, right? Easy. Everything is easy. Let's do the math. So that's going to be 8.8. So my supply is from here all the way here. So that's going to be the length is 8.8. So we're going to put 8.8 plus the other portion is going to be what? 23.5. That's going to be 23.5. That's going to be equal to 32.3, right? So if you round this up, that would be 30 feet. 33 feet. Okay, we're going to see see how much is that. It says 23 actually right here, right? So what we're going to do in here is analyze a little bit more on this. So trunk is 9 and run out is 23. The trunk is what is connected to the equipment, so that's 9, and then the run out is 23. So what we're going to do in here is see, it's rounding it up. This is connected to the equipment, is considering this as a trunk, and this is 8.8. So if we round it up, that's going to be what? That's going to be 9. The same thing in here. This is considered a run out because it's coming right after the box, which is 23.5. And then we're going to go check in here. There we go. We have 23. All right. And this is 9. So now, as you can see, we lose a lot of pressure in equivalent lengths, in the fittings especially. So we're going to have like 115, and then you have in here, see, fitting 1, let's go check, that's 35. The other one, let's go check, that's 20, and the other one in here, let's go check, that's 60. So if you add those equivalent lengths, you're going to be able to find the total equivalent length in fittings. But now we didn't check on this one. See, this is how it looks at distribution box in equivalent length. Okay, so it's the same process like we did for the previous one. So once you have all these values, as you can see, you add up the equivalent length of the total length of supply, the total length of return, and you add them up, and there you go, you have the total effective length. You divide the 0.24 divided by this, you have the friction rate. Okay, so since my friction rate is between ACCA wedge, which is this, as we were talking about, is right here, right? So I am within the ACCA wedge. I'm within that, which means my design is excellent. All right. So I might make, I'm gonna make another video about this, about the total effective length and friction rate in another time. So I hope you enjoyed this video, and subscribe and like and comment. All right, I'll see you in the next video. Thank you so much.